Right, folks. Question 8 of the exam paper dealt for 12 marks with probability. The question said, A and B are two events such that the probability of A happening 0.3, probability of B happening 0.25, and the probability of A or B happening being 0.5. Now remember, this is probability. Another way to write this is A intersect B is 0.5. Now they say, with the help of a Venn diagram. So we're asking you to draw the Venn diagram. Now let's see, how do I represent this on a Venn diagram? Clearly, there is some intersection happening in my Venn diagram. Okay, so I've got two sets that intersect. The probability of them intersecting, let's put a variable there, x or p or k, whatever that you want to have in that place. This is A and this is B. The probability of just this A component will then be 0.35 minus that part that lies over here in the intersection. Now remember, why is that the case? Well, probability of A is that whole circle there, but there's some intersection with B. If I add this to that, I get 0.35. Now the same for the probability of B will be what I have been given for this section then is 0.25 minus the little bit where it overlaps. Okay, folks, so that is quite nice. We can now work with what they gave us. Now they say A, the probability of A and B. Now the AND indicates a union of the two. So that probability, by the rules you know, is probability of A, okay, plus the probability of B happening minus the probability of A or B. So the intersection of the two. Okay, that's usually the rule that we're going to use. Now please remember, they said to us the probability of A or B is 0.5. A or B. So I'm talking about it belonging to either A or to B. And it's a 3-mark question, so it's really not that difficult. Okay, so if it belongs to A or B, I can say immediately that it's this probability 0.35 minus x plus the x plus the 0.25 minus x, and that must result in a 0.5. If I add this lot together, 0.5 plus 0.25 is 0.6, minus x plus x is nothing, so minus x is 0.5. Okay, what do I get? I get that x therefore is 0.1. Okay, so that's one way to look at it, by looking at this Venn diagram itself. Okay, folks, the alternative would be to say that the probability of A and B is equal to the probability of A plus the probability of B minus the point where they intersect. A intersect B. I've got the probability of A, it's 0.35. I've got the probability of B, it's 0.25. The probability of that intersection was given to me as 0.5. So I remove the intersection. Remember, why do I do that? Because if I add these two together, I've added this twice. So I've got to remove one of the intersections. So this gives me 0.6 minus 0.5, which leaves me with 0.1. I like this one. It makes better sense to me. Okay, so whatever which one you want to work with, you go and you continue working with that. Okay, now let's have a look here. Part B. They ask us to find the probability of a complement, of whatever we're working with lying in the complement of A. Okay, so we know that this rule is 1 minus the probability of basically A. Now A is 1 minus the probability of A is 0.35, and that gives you a result of 0.65. Now the first one was for 3 marks, the second one is for 2 marks. Okay, then the third question. I'm going to move up to that point. The third question, C, is asking us to find the probability of A complement or B. Okay, the probability of A complement or B. Now we know that that's the probability of A plus the probability of B minus probability of A complement intersect with B. Okay, so clearly you know your rule. Your probability of A complement we just found, 0.65. The probability of B is 0.25. And the probability of the intersection of A complement with B, intersection of A complement with B, is 0.15. Okay, this one is for a beautiful 4 marks. So let's see, 0.65 plus that is 0.9 minus 0.15 is 0.75. Wow, that's beautiful. I absolutely like this. Probability is not difficult, you just need to know your rules quite well. Then the last mark, or the last question here, which was obviously for the remaining marks. This is 7, 8, 9, so it's for 3 marks. They're asking us whether A and B are independent events. Are A and B independent events? Now what do we know? For independent events, we must show that the probability of A intersect B, okay, that probability will then be equal to the probability. Let's first start with this one. This probability is the probability of A multiplied by the probability of B. Okay, now remember we already have information here that we can use. So this gives me 0.35 as a probability of A. I multiply it with 0.25 and I get a result of 0.0875. I want that to be the same as the probability of A intersect B. The two things have to be the same, then the events are independent. But that component I found here to be 0.1. So these two things are not the same, which means that my events are not independent. Okay, so therefore A and B are not independent because these two things don't give me the same result. That was for 3 marks. Now let's just tell you where your marks went to. In number C, for stating the rule, you got a mark. Okay? Then for the substitution, there a mark, here a mark, and then finally, remember, because you worked out the complement over here, so it's just a matter of plugging it in, and then a mark for your final answer. The probability here was 1 for the rule and 1 for the answer. It's really just plug and play, if you wish. Okay, and then the last one, you got a mark for calculating this probability correctly. Mark there, a mark there, and then the last mark, you've already calculated this, was then for the interpretation. Those two are not giving you the same thing, so the rules are not, or the events are not independent. Okay folks, if that helped you, please like the video clip, and also please subscribe so we can grow the channel. Okay, I hope that helped you.